Hi, I'm Jim Gibson with CableSupply.com, and today we're going to look at communications models that are used, network models that are used in computers today to talk to each other. So this is not software, let's say, that like Word or Excel or something like that. What we're actually talking about is how the computer on your desk talks to your printer, how the computer on your desk goes to the internet, how the computer on your desk receives stuff from the internet. This is communication between computers and between equipment on a network. So the network is your routers, your switches, your cable, the stuff like that. And then of course you have software on your computer, which is totally different. This lesson probably is geared more towards people who have interest in working in IT, or who are working in IT and need a little bit more in depth on what's going on behind the scenes, on the wires, let's say. And these are things that you should know. You should know the vernacular, the descriptions, because if you have a problem and you need to communicate that, people in IT basically are using this thing right here, which are called layers. So they're talking about different problems. If you have a layer 1 problem, that means you didn't plug your patch cord into the jack. If you have a data link problem, you're probably having a switch issue. Network problem, something to do with IP addressing, which we're going to have a video on in the future, explaining how to do subnetting and things like that, which just hopefully make your life a lot easier. Router, layer 4, and above, we're going to talk about those things in that way. You need to use the right terminology. So let's go through these quickly. This is the open system interconnection model, and it starts out with application, presentation. Now, application is things like HTTPS, things like that. It's not actually your application, let's say from Microsoft. Okay, so if you have a Word document and you're trying to send it to the printer, well, the Word document is above this, and then once you try to send it to the printer, the application layer picks it up and does it from there. So this is not anything to do with Microsoft software, Word, Excel, things like that, or similar type of software that appears on your screen. You don't actually see this on your screen, by the way. This won't appear in front of you. The computer won't say, next we're going into the presentation layer, and then next we're going into the session layer. It doesn't say any of that. This is what happens behind the scene, but it's followed by your computer software that needs to communicate to another computer somewhere else outside of itself. So it uses these models here, and we're going to talk about particularly what model it actually uses. But in this case, if you're an IT person or an aspiring IT person, then you should have this memorized here, the different layers and what they do. So next is session. That pretty much does start and stop and control of data into the transport layer. So each of these layers communicate to the layer below it and the layer above it. So if you're working in the application layer, it's going to go to the presentation layer. That's where encryption takes place. Then it's going to go to the session layer. That's your start-stop control of the session, and then it's going to go into your transport layer that uses protocols over here, TCPIP or UDP. Then it's going to go to an IP address, a router, and then it's going to go to the data section, the switch, and then it's going to go to the hub. So they're done in order like this. This is the order of the OSI model. And this is how they communicate. So you're sending something to the transport layer, it does its thing, it sends it to the network layer does its thing, sends it to the data link layer. Once it hits the data link layer, then it goes to the physical layer, okay? And that's what a lot of my videos are on, is on the physical layer, and what what cable to use, what jacks to use, how to cable, what color cable goes where, and how to punch down, and all the real nitty-gritty, hands-on type of stuff. You're going to see a lot of videos on that. So this is the OSI model, and you should have it memorized. And let me tell you, if you're just trying to memorize a bulk, I'm not a memory type of person. I like concepts. But in this case, I had to memorize this many, many years ago, and I've never forgotten. And that's why I wrote it in blue here, APSTNDP. And how I memorize that is all people seem to need data processing. I just use that phrase. You know, and there's a couple of phrases out there. There's one that's about ninja pizza eaters or something, and don't talk to salesmen or something like that. But this is the phrase I use. All people seem to need data processing. And you could tell I memorized that, oh gosh, 15 years ago, 10 years ago, more than that. So that's memorized. And so when I have an issue now, actually I don't even think of it now, but when I have an issue, I already know that if it's a network issue, it's a layer 3 issue. If it's something going on in the switch, it's a layer 2 switch. It really helps in cybersecurity to know what layer you're in here. And then, of course, the other model is called Transport Control Protocol model, and that's TCP/IP. So that's what it's called, TCPIP. And TCP stands for Transmission Control Protocol. Now, these are two different models here, okay? And you need actually to learn both models. However, this model is not used in computers today. This is not the model that's used. This is the model that's used in networking today. You know, I remember my son years ago when he first started in networking back in the 90s, something like that maybe. You know, he started doing Cisco training and stuff like that. In his first Cisco class, you got to learn this stuff. And he studied really hard the OSI model. Then at the end, he said, it's no longer used. So well, what did I waste my time for? Why did I do that, Dad? I wasted all this time. And he went on to CCNA voice, CCNA security, CCNA route switch. He did a lot of Cisco stuff. He's really, really well educated technician. But to make a long story short, he had to learn all this. And the reason you got to learn this as an IT person is because this is the language of networking. This is what you have to know when you're communicating to other people. When you read a white paper and it talks about layer 3 issues. When you read about a firewall, what layer does it go up to in the firewall? What does it protect? Intrusion protection. This is something that you got to have down. You just have to know just like that. And it has to be something you don't have to think about too much. But if you have to, you know, if you have to write it out, then it's all people seem to need data processing. And that's how I use the first letter in each word. All people seem to need data processing. That helps me remember it. And I always remember the physical is layer 1. That's where it all starts. It starts in layer 1. Now, if the computer is talking out, it goes this way. If the computer is receiving, it goes this way. So think it through like that. You know, the model there. Now, the difference between the two, both were pretty much developed about the same time in the 70s, still applicable today, and thank God there's really only one that we use today in networking, because there used to be a lot of different models here. IBM had their own, HP had their own, all the different major companies had their own, and so it just became a nightmare. But today the standard is TCP/IP. Let's talk a little bit about the history again. It started in the 70s. This is a great organization, ISO organization, International Standards Organization. They came up with this, but they were very slow in processing. And in the meantime, DARPA and some volunteers in the country came up with the TCP/IP protocol stack. And when they came up with this protocol stack, this is the one that's basically has been accepted in the IT world today. So you're going to see a lot of this, you're going to see a lot of interaction with this, but in reality, when you're talking about this protocol stack, they usually use the 7 layers of the OSI model. So I broke it down a little bit here and showed you how they relate to each other. So, you know, layer 4, transport, that's obvious, okay? So layer 3 network, we call it layer 3 network, but the TCP/IP calls it Internet. And then, of course, it combines these two. The data link and the physical is network access. if you go, actually, and you're going to study this in detail, you're going to find out that the data link layer has 2 layers underneath it. But to me, this is just theory. It's practical because you got to know where you're at when you're dealing with people talking to you about firewalls and intrusion prevention systems and all sorts of things like that. They will often talk about the different layers and how their equipment, how their software interfaces with the different layers. So, but in reality, this is the one that got adopted by everyone, and this is what's in everything that communicates on the internet. If you have a NIC card, it's using TCPIP at this point. And all they did is simplify it. So layer 5, 6, and 7 is just all one here. And this is really where most of the stuff is going on networks anyway, is going to be through 1 through 4. Again, firewalls, intrusion prevention, detection systems, and everything else are going to go farther up the stack than there. So this is where it is that most people deal with. And it's the way I remembered this is it's just at in. So if you're going to take some of these certification courses, they're going to ask you questions that you're going to have to think through. So they're going to say, oh, we have an IP issue. What layer is it? And sometimes it's really tricky. They won't say network. They'll say, is it transport layer or is it the internet layer? And you're saying, well, layer 3 is network. And then you have to remember that the internet and the network layer are the same. It's the same layer. It's all layer 3. So it's a little bit difficult sometimes. Cisco exams can be difficult, okay? They're not, you just don't read through a book and take the exam. At least I can't. You got to really study this stuff. So over here I got the protocols. What are the different protocols? Well, in this area you have HTTP, HTTPS, POP3, that's your mail protocol, SMTP, things like that, a lot more. There's a lot of protocols here in these top 3 layers, application layer, a lot of protocols in that top 3 layers. Again, TCPIP deals with all 3 in the application layer. This is how a network engineer thinks. This area is more of how a programmer would think. But in reality, if you're an IT guy, you're probably not developing unique programs for word processing. That would be a waste of time. So you're thinking through these areas. So the way I remember it again, AT at in is for your TCP/IP. And again, the TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. Now, who developed this? We already talked about that this in the 70s was started. It took a long time for them to come up with the 7 layers and how it fits. These are not protocols. Remember, these are layers. And the protocols over here can, everyone's, well, I don't know if they've ever changed, but they can be fitted in here in different, so the model always remains the same. It's the protocols may change. I don't remember them changing ever. There might be some added up here in the application layer. But anyway, how did this come about? Well, at the same time, both of these groups were working on how to get 2 computers to communicate with each other. And if you're a millennial and younger, you don't remember the time that computers didn't communicate with each other. In fact, there used to be a joke, they used to call it the Sneakernet, and sneakers being a reference to running shoes before there was running shoes. And they would take little diskettes, they were little square things that had a spinning disc inside. You plug it in, you push a button, and you could save things to it. Well, they would call it a Sneakernet when you would save a document in that little diskette, and then you would grab that document and you'd run over to someone else's computer and plug it in, because that's the best you could do. Well, Apple came out, I think, with one of the first network protocols. It was called Apple Talk, and that was a great invention. And of course, you've had some other protocols before that, and now that I'm thinking, IBM, things like that. But the Apple was the one that was mostly used in local areas, in an office, things like that. So, and that was called Sneakernet. That was a a funny term back then. But that's what they had. He didn't have the plug in the wall at the time. That's only recently in the last 20 years or whatever. So TCP came about through DARPA and some volunteers back in the 70s and probably the early 80s. And DARPA stands for Defense Advanced Research Project Agency. It's part of the Department of Defense. And back then they were thinking, you know, if we had nuclear war, how do we continue to have communications? How do we have a self-healing network that could work in such a way that if we lost half our networks, we could still communicate with the other half that's there. If we lost a lot of our links, we could still communicate and everything else. So they wanted a healing, robust idea, a network that would work, and they needed to come up with these advanced ideas on how to do it. And that was advanced back then, by the way. And so them and some volunteers came up with TCPIP, and that's the protocol stack that you're going to see today in your computer. It supports TCPIP. All computers have it, all printers have it, routers, switches, things like that. Hubs do not, but routers and switches and all understand TCPIP, and that's how you communicate from one computer to another. Either a computer across the office, if you plug into the wall and they plug into the wall and they got a switch in the back room somewhere, that's what they're going to use. They're going to use this protocol stack here to communicate to each other. Now, if you know, this became popular because they were quicker at developing TCPIP than they were the OSI model. So that's enough with history. DARPA is a great organization. It's part of the Defense Department. But they've come up with a lot of ideas that we use today. Another idea that you will instantly recognize when I say it, they were the ones that came up with GPS. They developed GPS, they designed GPS, they came up with the implementation of GPS. It was for the Defense Department, and they opened it up to civilians, and now you can drive down the street and drive in circles, sometimes because your GPS gets confused. But pretty much it works pretty well, but that has nothing to do with TCPIP. So that's where we're at. So over here I got some of the protocols. So we have, in the application layer, we're going to have TTPS, HTTP, I'm sorry, POP3 and SMTP. These are all just an example. There's a lot more in there. However, when we get to the transport layer, there's only two ones that I know in the transport layer, and that's TCP, UDP. Maybe I'll think of another one, but I can't think of anything else. And TCP, of course, Transmission Control Protocol. Now, what is Transmission Control Protocol? Well, that's another video, but I'll just give you a highlight here, okay? So when you're talking, your computer's talking to another computer, your computer is monitoring the speed of sending that data from your computer to their computer. And they're making sure that that other computer is talking back, that it got the data, that it didn't get the data, that it needs to resend the data. Does it need to send the data faster to speed it up, or does it need to slow down that data? That's called windowing. And we're going to talk about that in another video. But that's TCP. So that's also where error correction and recovery is in layer 4. Flow control, layer 4. That's all TCP. So they're going to control how fast the data moves, to how much data is sent at any one time to the other computer. You know, the ones and zeros, the binary speed. And also, if the other computer says, hey, I got this segment and these packets or whatever, but I didn't get them all the rest, well, then it will resend. So the big thing you got to remember is it resends and it sets speed, TCP. So you're going to use it for browsing. You're going to use it when you're sending a document somewhere that you want to make sure it gets there and it is complete and accurate. That's going to be TCP. Now UDP stands for User Datagram Protocol, and what it actually does is it's used in VoIP phones. So if you have a VoIP phone, you're using that protocol on layer 4, on the transport layer, and that's going to be UDP. And what happens with UDP is it's pretty much the computer says, I don't care if you get it or not, I'm just going to send it out, and I'm going to send it out at this speed. And if you get it, great. If you don't bother me, because I'm not going to resend. So UDP does not do error correction. You got to remember that. UDP, layer 4, does not do error correction. It just sends the stuff out. And if you got it, great. You know, it's sort of like listening on the radio. You're going down the road, you're listening to that radio, and they start talking about something, and all of a sudden you go under a bridge and it stops, and then you come out from the other and you say, well, I missed something. Well, that's life. They're not going to go back and retell you what you missed. So it's the same thing with UDP. So you're going to use VoIP on UDP, and you're going to use video or any type of audio. If you're downloading information or a song or something like that, it's not going to have error correction. It's not going to have retransmission. That's TCP. It's going to be UDP. So UDP is, I send it. If you got it, great. If you don't bother me. Just think of it that way with UDP. But that's going to be at layer 4 here, transport layer under TCPIP. And again, this is what's used today. You got to know this to communicate and to understand what's going on in IT when people talk to you. But really, this model is not used today. This is the model that's used today. And then, of course, the next thing is going to be IP. This is where your addresses are, your send and receive addresses, things like that. When you communicate, when routers communicate to each other, they're going to be using IP. And it's going to be one of 2 versions. It's going to be IP version 4 or IP version 6. And again, I'm going to have videos most likely on both of them. I haven't made the videos yet. Excuse me. But I'm going to make videos on both and show you how to do subnetting, how to figure out what's going on in your network. Sometimes people don't understand subnetting, and they pick an IP address for their computer that's completely out of range, and they can't figure out why it's not working. Or they have other issues with other protocols. So that's going to be layer 3, your internet layer, and that's going to be IP. And then, of course, your data link layer and your physical is always going to be Ethernet. Sometimes people confuse that, and they say, well, I'm talking to Ethernet, I'm talking to the internet with my Ethernet. No, Ethernet stays on this side of the router. So you talk to a router in Ethernet. It does have a port that connects the Ethernet to the network through the switch, but in reality, Ethernet is not IP. So these things you need to memorize. All people seem to need data processing 1 through 7. At, in, you need to have those memorized. Basic idea of protocols and where they fit within the stack. And then the last thing you have is, a lot of times when you're talking about TCP and UDP, you're talking about segments. That's the phrase that's used, segments. UDP, TCP segments. When you're talking about IP, you're talking about IP packets. And when you're talking about Ethernet, you're talking about frame. So you hear frame relay, things like that. It's all Ethernet. That's not necessarily IP. When you're talking about IP, you're talking about packets being sent. Sometimes people interchange these. It's not a big deal, but the way I remembered this is SPF. You know, and that's your protection you put on you when you're out in the sun, has a certain rating, and that's an easy way to remember it, SPF. Just remember it relates to the TCPIP protocol. So it's a frame packet segment. I hope this has been enlightening. It can be sometimes boring, but this is something you need to know if you're an IT professional, or if you're expecting to go into IT to learn these things or to communicate. You really need to know these things. You can't guess at this. And you know, you can't say, well, this is not the most interesting thing in the world, so I won't learn it. If you're going to be a professional IT person, you really need to memorize this stuff and how it fits. You know, you might want to write this all out and memorize it, rewrite it. The way I learned it is I rewrote it over and over and over again. All people seem to need data processing, in, out, at, in, and SPF, and just an idea of what happens on each of the layers. Again, my name is Jim Gibson with CableSupply.com, and I want to thank you for watching this video. And we're going to have more videos on the intricacy of a network. So we're going to be talking about TCP, UDP in detail. We're going to be talking about the most difficult thing I think people have is subnetting. And I'm going to teach you a couple different ways to subnet. You're not going to need a subnet calculator. It's just a little bit of memory work. And as soon as you can do the memory work, you're going to be able to figure out every single IP address. Just by someone talking to you, you're going to know what the network is and what the broadcast is. You're going to know how many IP addresses are in between. So I'm going to be doing that in the future, and we're going to be discussing that. And all this is beyond that layer 1 stuff that I've been talking about in many videos. They give you practical experience in layer 1. But again, Jim Gibson, CableSupply.com. If you like what you see and you have need for layer 1 stuff, please go to our website, please purchase. We're also on Amazon. We have a lot of products, not all our products, but a lot of our products are on Amazon. We're happy to help you in any way we can. Thank you for watching the video. Have a great day. Hi, this is Jim with CableSupply.com. Hi, this is Jim from CableSupply.com. Hi, this is Jim with CableSupply.com, and today I'm going to show you how to cut a hole in the drywall.
This is David signing out. You stay classy, Internet.